Hi everyone, and welcome to this very special Dawn Hangout. We will be talking about the Dawn mission and Hubble Inspired. We have a whole bunch of awesome people here, so why don't I get started? Oh, Judy. Bye, Judy. Sorry. So we have Brittany Schmidt down on the end here. Hello.
Hey there, sorry about that.
Hi. So we'll be talking some about the Dawn mission that finished up its imaging of Vesta, and it's on its way to Ceres, and how it's been inspired by images of the Hubble Space Telescope. And we have our very special guest with us today, Jian-Yang Li. So hello, Jian-Yang.
Hello. Sorry, I was muted.
Oh, it's fine. And Max Mutchler, whose
Hello.
lower third is working. Excellent. And we also have Whitney Cobb, who will be answering your questions on Twitter. So you can ask questions of her at NASA_Dawn on Twitter. She'll be monitoring questions there, sending in questions to the broadcast. You can also ask questions or leave comments on YouTube. You're watching this on YouTube, on the Google Plus event page, and also using the Q&A app through Google Hangouts. We'll be monitoring that as well. So thank you guys for coming. Why don't we get started with a little introduction of our guests. Maybe you can introduce yourselves, tell us what you do, and maybe just a brief overview of your work with Ceres and Hubble. Jian-Yang, you want to start?
Sure. Okay, so my name is Jian-Yang, as you call that, and I'm working at Planetary Science Institute as a research scientist. And my research interest is on small bodies, asteroids and planets, and I now work on Dawn mission as a participating scientist. So I started to work on Ceres like 7 years ago in 2005 when I was still a PhD student.
Very cool. And Max?
Yeah, I'm Max Mutchler. I work at the Space Telescope Science Institute in Baltimore, Maryland. And for those of you that don't know, that's where we control the mission of the Hubble Space Telescope. So I've been working on the entire Hubble mission, and I'm an expert on Hubble's cameras, and I work with a fair number of people in the planetary science community, including the amazing Dawn team, which, I think it was back in 2006 when I started collaborating with, this team, and we started generating. Well, there was earlier Hubble observations back in the 1990s and earlier, but that's when I started a series of observations going back, from the mid-2000s and continues to today.
Cool. And Brittany, of course, our lovely co-host for all of these Hangouts.
Sure. Hi everyone, I'm Brittany Schmidt. I'm an assistant professor here at Georgia Tech in Atlanta, Georgia. And I'm a member of the Dawn Mission Education and Public Outreach team. And I'm really excited about today's group of people because actually they're part of the reason that I got my PhD and how I got my PhD. So Max and Jian-Yang and I collaborated on a number of programs while I was a grad student, and we continue to work together. We'll be telling you a little bit today about some future observations that we'll be using Hubble to make that will allow us actually a chance to look for satellites of Ceres and to get ready for the close approach and orbit insertion into Ceres for the Dawn mission. So even though we've already passed Vesta, we're still using data and a collaboration with Hubble Space Telescope to make science of small bodies and Dawn science possible. And so that's kind of what we wanted to share with you today, is the history of the collaboration between Space Telescope and Hubble Space Telescope, and then the Dawn mission, in order to understand these really interesting objects in the solar system. So that's why we've got this panel here today, because that's still going on. A lot of the time I think we get really caught up in we need higher resolution pictures, we need better pictures, and we need new. And it's amazing what we can still do with the tools that we sent up into space, a decade ago or more, using still instruments on Hubble and collaborating between these missions. So I'm really excited to share with you guys that, and to let Max and Jian-Yang, who've been doing a lot of that work as well, get a chance to share that with you as well.
Yeah, so we started off with the banner graphic you guys made for this Hangout, which shows these two different views of Vesta. So these high-resolution images of Vesta that we got from the Dawn spacecraft, but also the Hubble images that helped inform the science before Dawn got there. Maybe you guys can start off by telling us a little bit about the kind of work that goes into making these images with the Hubble Space Telescope and what they show.
Yeah, well, Jian-Yang really led the mapping effort. Maybe I could talk a little bit about the raw images, that we take with Hubble and the steps that I go through to clean them up and make them the highest resolution images we can possibly make. And I can just screen share for a second here to give you a sense of what the raw Hubble data looks like when it comes down. Let me just pull something up here. All right, so what I'm showing right here, can you see that, these blue, is everybody seeing that?
Yep.
All right, so what you see there on the left, it looks like a pile of blue Legos, basically. That's actually what Vesta looks like in, at the time, I guess we were using the Wide Field Planetary Camera 2. You'll hear us talk about a couple of different Hubble cameras, partly because new cameras have been installed in Hubble, but also because sometimes we've had one fail, and then we have to go back to using an older one. And so throughout this whole story, we're using both the rather old Wide Field Planetary Camera 2, which was installed in 1993 by astronauts. Then there's the Advanced Camera for Surveys that was installed in 2002. And now we have that camera repaired plus the new Wide Field Camera 3 that was installed in 2009. So you'll hear us keep using those terms for the cameras, and we've used them all from time to time. So what we're looking at here is on the left, again, that pile of blue Legos is what Vesta looks like. And you think, well, gee, I've seen a lot of really amazing Hubble images, and that doesn't look so amazing. It looks pretty low resolution, and it is. It's because Vesta is quite small, even though it's really close by compared to a lot of the things we look at with Hubble. It's quite small, and you can see individual pixels there. And so, but with kind of clever observing strategy, we've actually used a couple different observing strategies, like where we shift the telescope around and take a lot of exposures by shifting the target around and sampling the image. We're able to combine them into the ones you see to the right there are ones where, in this case, where we've actually used our knowledge of the telescope optics, what we call the point spread function, to resample the image intelligently and try to enhance any features that are there. So you can see it starts to look less like a pile of Legos and a little bit more like an interesting world in the solar system. You see some features there that in the next step, Jian-Yang Li will describe his process of turning that into a very detailed map of the surface of Vesta.
Jian-Yang?
Yes. So, okay, after Max did the fantastic job for the first step of the processing, what we do is that we try to make this small round dot, or maybe not dot, small round disk, and we take a lot of them at when Vesta rotated to us, facing us with different sides, and then we put them all together, and we try to unwrap them to just like we make a map of the Earth. We make a map, just put all of them together and make a map of Vesta. And okay, so Max actually is showing a lot of these images taken of the different sides of Vesta, and then that's those images that we used in order to make the full map.
Yeah, I was showing one example there, and now I'm showing we took a whole bunch of images, obviously, to capture Vesta rotating in this case.
Okay, why are they blue?
That's just sort of arbitrary.
Okay.
We actually took images in several filters so that we could make a color movie, and I can show that in a second. In addition to the maps that Jian-Yang made, we made a kind of a crude little movie. I actually, in a way, there's no color here. I mean, this is just sort of a color I applied because I find it easier on my eyes to look at than just, say, a grayscale image. In fact, we took images at 3 different filters. This one happens to be one that's kind of close to the UV, I guess, ultraviolet light. But the blue is sort of irrelevant. It's just sort of a helpful aid. In in our tools, we can apply any color to images like this, and I'm often like choosing a color not based on what color the object actually is, but on what allows my eye to see the most detail.
Very cool.
Right, yeah. Nicole, if you can keep those the images that Max showed on the screen for a while, I can just talk about a little bit feature on those disks, and then so we'll know if we'll talk about a little more details about what we're doing to take those images and transfer them to Max. So if you look at those images carefully, these images actually show you some features on Vesta. If you start from the maybe third image in the second row, there's a bright patch, and then if you go along that row, and you will see the bright patch actually moves. That actually shows that the rotation of Vesta. And then what we did is that we take this disk and we apply some kind of corrections. By correction, I mean, over here you see the center of disk appears to be brighter generally than the edge of disk. So we apply some kind of correction to take it out, and then we unwrap it to a flat surface that project it to a map, and then one of these images will give us one patch on the map. And then we just take all these all these disks, all these patches, and put them on the map, and then one by one at their correct location. And then that way we can make a nice map at the end.
Do you want to show the color map of Vesta? Oh, sorry, Ceres. I have a color map of Ceres. Do you want to switch to that?
Yeah, let me try to pull that up here.
Oh, okay.
You guys can talk amongst yourselves.
Jian-Yang, I know. So if you thought about if someone wants to actually show that graphic again, the graphic that we put out for the Hangout.
Sure, I'll get that up.
Look at it. The reason that we put this graphic together was really to show how complementary these data sets are. So now that you've seen images of Vesta from Hubble, now kind of what we're going to do is we're going to show you the map of Vesta from Hubble and how it relates to what we actually were able to get on the Dawn team. So Jian-Yang is one of the investigators. He's a participating scientist on the Dawn mission, which means that he joined the mission as a scientist after it launched. You get a chance to apply for an additional grant to join the mission to add to the science team. So Jian-Yang is one of the people that's actually joined as a participating scientist. And so what this graphic is really showing you is that that's a map, just like he's just described, of Vesta, using those same images that you just saw Max show you. So you take each of those individual images and add it up. So Jian-Yang, did you want to kind of describe what this is showing here in terms of the data from Hubble and the data from Vesta, or
Sure.
from Dawn?
Sure, yeah. So what you're seeing here is actually the topography map. By that we mean this map tells us how high, what's the altitude of each point in the map on Vesta. And the whole banner is actually made out of HST and Hubble images. I mean the background banner, the low resolution map, and then there's a blowout at the center where in Hubble map it's the highest point, and then in the blowout you can see the details. And this part is actually the topography we derived from the Dawn images. And over here you can see you can see a lot more details than what you can see in the Hubble map. But if you compare the overall agreement, I mean, if you compare these two parts, you can see that they overall agree with each other very well. I would say the agreement is excellent. Considering considering the resolution of Hubble images, it's about, let's see, 40 kilometers per pixel. And then for Dawn images, these images are like 50 meters per pixel. You can see that what kind of excellent job that Hubble images have done in order, for us to see what the surface is like, despite its relatively much lower resolution than Dawn images. So I think that's very that's exciting.
Yeah, I thought it was really amazing that when we got the data back from Vesta, just how well it matched up. It really shows kind of that proof of concept that that the Hubble cameras are really pretty excellent and really demonstrate what you can do even from far away. We do that in a number of ways in astronomy. We use ground-based telescopes with a variety of different resolution to compare to spacecraft data. There's other examples too of how smaller ground-based telescopes have been used to do stuff like track the phase behavior. So if you think about the full moon, right? It rotates into full, it gets super bright. That's actually the phase behavior of the moon. It's actually telling you about the particulates on the moon's surface. So we did a similar survey using both ground-based telescopes and some Hubble data to try to understand the brightness function or the phase behavior of Vesta, and that's something that you also participated in, right, Jian-Yang?
Yes, that's right.
So it's just another way of using a bunch of different data sets. We always need a spacecraft to at least confirm and to tell us new things. If we couldn't see the little small craters, we couldn't see the detail, we couldn't see that Rhea Silvia was two basins, but we could see that Rhea Silvia was there, and that's what we're hoping to be able to do when we actually get to Ceres. So, Max, did you have your Ceres data up, or?
I'm sorry, it keeps failing on me. Like, I don't know why, but I'll keep trying. But I do have the one for Ceres when we get to Ceres.
Can you guys maybe talk about some of the science that Hubble, that you were able to figure out from the Hubble images, and then how that was furthered by the Dawn mission, the Dawn images of Vesta?
Sure. Yeah. So when we take the images of Vesta using Hubble telescope, we actually took the images at several different colors, and then by comparing the images at different colors, we were able to figure out what are on the surface and what kind of change when we move from one place to another on the surface of Vesta. And that technique is called color ratioing. We are just taking the ratio of different different images at different wavelength, different colors. And so we actually generated maps from just like what we did for Ceres. We generated the maps for Vesta, and again the resolution of that maps is those maps are kind of low, but then we learned that one side of Vesta is kind of dark, and the other side is kind of bright. And then the dark side, we figure that is mostly like rich in one kind of minerals called eucharite, and the other side, which the bright side, is has more minerals called the diogenite. So those are the different minerals we can see from Hubble images, and also we can see a lot of from one area to another area, we can see different compositions in it. And when Dawn gets there, and my colleagues Vishnu Reddy and others, they actually did very detailed comparison of the maps, similarly generated but using Dawn data with the maps generated with Hubble data. And what they say is that you can actually find all kinds of for the features you see in Hubble maps, you can find the corresponding features in Dawn maps. So that's an excellent match. And then, but on the other hand, because Dawn has a much higher resolution, that gives us a lot more information about what we could not learn from Hubble images. For example, I can give you one example, which is one area we call that Mutchler region. That region is, I think, a lot of people might be able to recognize it. That region has like 3 big craters forming a kind of snowman shape.
Snowman, yeah.
Yes, exactly. So, from Hubble, we just saw there's probably a dark blob over there, and we thought that area is kind of interesting. It might have a lot of eucharite, and it might be old. But then when Dawn gets there, from those images, looking at the snowman region images, what we learned is actually those 3 craters are kind of young, and the surface is dark on one side and not that dark on the other half. And then also there's a lot of interesting things going on the bottom of the Mutchler crater, the largest crater of the snowman craters. And there are some interesting features over there, such as possibly outgassing, possibly the possible phenomena related to volatiles at the bottom of the crater. So basically, they saw a lot of featureless, rimless pits at the bottom of the crater, we're still in the process of fully understanding this region. But Hubble just dawn data just advanced our knowledge a lot. That's what Hubble could not have done.
Yeah, and I can't reiterate enough how gratifying it was to see that paper by Vishnu Reddy that John Yang just talked about. Verifying that the observations we did with Hubble were valid. And that the crude features we saw at low resolution with Hubble were actually there, because any astronomer knows this, that you see that we're kind of working the data really hard. We have that pile of Legos at the beginning, and then we're massaging it, and we're doing all these special tricks to try to bring out all these features. And the concern is always that you're manufacturing features that aren't really there. That you're torturing the data so much until you get something that isn't really real in the image. And you like to have that verification that yes, these things really are real, because of course, in the case of Vesta and Ceres, we have the Dawn spacecraft arriving to verify these things for us. But of course, most of the objects in the solar system will never have a spacecraft visit. And so we need to know that these observations we're doing with Hubble, or any other tricks we're using from ground-based adaptive optics or things like that, that we're actually getting real results. We're observing real features, even at low resolution. And so it was very heartening to hear that.
Yeah, so that image is actually showing the feature that they were just talking about.
I had to show this.
Yeah, the snowman craters. So I mean, it's appropriate for the holidays.
Holidays.
Right? So that region is the area that in the Dawn or then in the Hubble images were kind of this big dark feature. And originally, it was kind of misinterpreted as a single big splotch, and it turns out to be much more detailed and much more complex than that. And there's some really interesting geology that it turns out. So we could actually see the feature. We knew something was interesting there with the Hubble data, and then when we went back, it was just even more interesting than we ever could have imagined, and was especially photogenic, shall we say.
Yes. So there's your greeting card that you guys can use. Straight for, looks like it came from Joe Wise, actually. So it came from the Dawn EPO team. Very cool.
Well, of course, we'd be remiss if we don't talk about the really big impact crater on Vesta as well.
Yeah.
Earlier observations, we're talking about some of the more recent observations of Vesta. Earlier observations of Vesta with Hubble, the most obvious things you see is this, well, it's not round. And it probably was round at one point, but it obviously endured a massive impact, which amazingly didn't disrupt the whole asteroid, because it looks like an enormous impact crater that's like, more than half the diameter of the whole planet, or protoplanet. And that sort of fit with a lot of other things we knew about Vesta and Vestoid asteroids and things like that. And it tells you a lot about the geology of Vesta. So that was another early contribution from Hubble in terms of understanding, the morphology of Vesta.
Yeah. So let's talk a little bit about what we're going to do for Ceres, or what already has been done for Ceres, and then what's kind of still left to be done, and what we can kind of guess about Ceres using the Hubble data. So so here you go. This is a great picture. So this is a picture of those two largest asteroids of Ceres, or I guess the first and third largest asteroids, because it's missing one. We're missing another one that the three of us actually worked together called Pallas, which is the object that is a lot like Ceres, but is about the same size as Vesta. That kind of completes that set. But that image right there is showing you some of the information that we got from Hubble for Ceres, and I got really excited. So when I was an undergraduate looking for graduate programs, I really desperately wanted to work on Europa. And at the end of the Galileo mission, not a lot of people were looking to fund new students. Funding for icy planets was going away, and so they weren't really looking for new students to study Europa. And so when I applied to UCLA, I actually got an email from Chris Russell, who's the PI of the Dawn mission and ended up being my thesis advisor. And what he did is to actually send me that paper, the very first paper about the first Hubble data of Ceres, and then a paper along with it that was just in production, interpreting not only the shape, but what could the interior be like of Ceres. So it was the very first paper that really suggested in a big way that Ceres is probably icy. And it was Hubble that gave us that. It was that very first picture that you just showed in 2004 of Ceres that showed us just how round it was, just how big it was, and just how different from every other asteroid out there it really could be. And so that was really exciting for me, and that ended up being a big career changer. Getting these papers about an icy, an ice ball sitting there in the middle of the asteroid belt that we might be able to go to with the spacecraft was an absolute. It was a huge career changer for me. So that's what I ended up working on was big asteroids instead of what I had planned on. I planned on working. So Hubble's done a lot for me, and it's done a lot for a lot of scientists in terms of what it could tell us about Ceres. So, Max, you actually worked on that data set, correct?
Yeah, there's kind of an interesting story there. I mean, I think I had been helping with the Vesta data, and I recall a telecon. This would have been like, I was actually just going through my emails just before this Hangout, just to remind myself the sequence of events. And it was a pretty cool summer in 2006, if you think about it, because the whole vote, the IAU vote on what is a planet, what is a dwarf planet was going on. And I didn't quite see it coming that Ceres was going to be like such a central figure in that whole debate, because here we are having a telecon in May, and we're kind of talking about the Vesta data and then talking about the Ceres data. And it was in that phone call that I realized that Jian-Yang had been working with. There was sort of two types of data. There was sort of some dithered data and some undithered data, and I think he had been working with the undithered data. And the dithering, when I say dither, that's these small telescope shifts, pointing shifts we do with the telescope. And I'm an expert on dealing with data like that, and I realized that we had the best data of Ceres ever, the highest resolution images, but it was going to take some effort to stitch it together into that image that you now see everywhere. If you go to Wikipedia and look up Ceres, there it is. And so I realized, I kind of made a mental note of that in that telecon, that, oh wow, we're sitting on the best image of Ceres ever. We got to really, work on this data and put that out. But then I kind of didn't do anything about it for a couple of months until August rolls around, and the IAU is voting on what is and isn't a planet, right, and a dwarf planet. And in the first, if you remember that history, in the first proposal that was put forward was very inclusive. It was not only going to include Pluto as a planet, but it was going to include Ceres as a planet. Yeah. So now here we have Ceres, which originally was designated as a planet back in the early 1800s when it was discovered. Then it got demoted to asteroid for the last 150 years. And now it's about to have its debut as a planet again. And we're sitting on the best data. The world has not seen yet the best image of Ceres yet. And so that really kicked me into gear to go get that data out of the archive and do what I do, which is, again, if you look at the raw data, it looks a little bit like a Lego pile, and applying actually a different technique. The first one I mentioned with Vesta was called deconvolution, where we're using the telescope point spread function to try to enhance the image. And in this case, it's different. We're taking images that were shifted slightly and then combining them and highly resampling them to try to extract as much spatial information as possible. And then there were, again, multiple filters so we could make a color image. And it's very challenging because not only because you're starting with the pile of Legos, but because Ceres is rotating. Between each frame, it's moving and rotating. And so I'll just start screen sharing here.
Actually, while you're doing that, we have a question that I think dovetails off of this from Ron Mader. He says, nerdy question, are there any lessons learned that help make current data sets available for future research? It sounds like this archival data was really important. Are there any lessons learned or things in general about this data being available that you can comment on?
Yeah, there sure are. I mean, we archive all of our data. And so the Hubble mission, we're well into our 23rd year. And
wow. There's
a ton of data in there. And obviously Hubble's a general observatory, so only some fraction of it is planetary data. But it's archived and publicly available. Like, we have a proprietary period for new data. So for the first year, it's only the science team that can work on it, so they can do a careful analysis and publish a paper. But after that year, it's anybody's game. And so we have been encouraging people to, consider it. Even high school kids, undergrads, amateur astronomers. I got to warn you, though, it's real data. It's not nice, pretty press release pictures. But there are a lot of amateur astronomers and and certainly high school students and who could do like a science fair project, or college students or grad students who could do, thesis type work. And we support that kind of archival research as well as new observations with Hubble. So the image I'm showing you was actually publicly available at the time that we had that telecon in the summer of 2006. In principle, anybody could have gotten it out of the archive and done what I did to enhance the image and produce the image that you see there. And so I'm actually going to go through a series, just kind of blink through a series of images here. You can kind of see Ceres rotating because there was a fair number of images taken over. As you can see, the dates and the hours rolling by there, different faces of Ceres that allowed us to see different features. And I just have to say that, not only was Ceres about to become a planet, but just looking at these images, you just have such a visceral reaction that this is not like some lifeless hunk of iron tumbling through the asteroid belt. This is when I would give talks and show this, I would say, if I told you this was Mars, you'd believe me. It looks like a planet, and it's round. It meets the roundness criteria of a dwarf planet, but you also see features rotating in and out of view, and it just looks like a real world to me. It doesn't, it kind of challenges your kind of Star Wars movie mentality of what an asteroid is.
Yeah.
And really makes you realize that this is at least a dwarf planet, if not a planet, and why it's in league with Pluto, and really a fascinating world in the solar system. And as Brittany was saying, one that's much, much closer to us than Pluto and Europa, and so possibly much more accessible. But we did release this image on the same day that the IAU vote ended, and obviously, as you know, like both Pluto and Ceres ended up as dwarf planets. Not planets, but nonetheless, it was still promoted from asteroid to dwarf planet, and so I was very proud that we were able to put out the best ever image of it on the day that it became a dwarf planet, and all the while knowing that its days were numbered, because when dawn arrives, this image is going to look very quaint.
Yeah. So we have a couple of comments. One amusing comment from Hugo Burnham and Toads, which he says he ripped off this catchphrase from Tony Darnell: "The Hubble huggers inspire the Dawn darlings." So I don't know if you've heard that one yet.
I like it.
Awesome. And then Writing with Robots asks, what specific things seen in the Hubble data on Ceres, maybe we can transition to that, are you most excited about checking out up close with Dawn?
Oh man, well if you take a look at that, you can see that unlike Vesta, there's no big giant impact basin. There's almost nothing. So one of the things that I've been doing on telescope data is to look at how you can estimate shapes and sizes and topography. And this is the best resolution on here is about 20 kilometers or so, which means that Ceres doesn't have any topography down to about 25 to 50 kilometers, which is really, really flat by anyone's standards. And that's really exciting because the places that we see that have that kind of flat topography are in fact made of ice. However, you'll notice there's not a whole lot on the surface. There's not big, huge dark splotches. There are a few spots. The thing that I'm sure Jian-Yang is going to show in a minute is that those change and go away depending on the wavelength. So whereas on Vesta, once we saw a dark region, it was pretty much there in a lot of in a lot of different wavelength regions. It's not true on Ceres. Ceres looks different in the UV, it looks different in the visible, it looks different in the IR. So we don't really have a good idea of what a lot of those features might mean. There's lots of speculation, but this is one of the places where resolution and having high-resolution spectroscopy and high-resolution images is really going to help us understand what it is that we're actually looking at. So that might be a good transition if we want to show the map, and then maybe Jian-Yang, you could talk a little bit about the surface of Ceres.
Yeah, sure.
Sure. Do you want me to show the Ceres maps?
Yeah, the Ceres map.
Yes.
Okay. I'll slowly
while
get that up.
putting that up, I want to point out that actually for Ceres images, that was taken by a different camera than what we used for Vesta. that camera was has a higher resolution than the camera we use for Vesta. So, but
Yeah.
that camera, unfortunately, that camera is gone now. It's dead. So we hope we wish it can last longer. But
Yeah.
anyway.
That was
Okay,
that was an unfortunate summer.
yeah, I was. Yeah, we originally planned to use that camera for Vesta, right? I still remember that, but then. But anyway, okay. So what you're seeing now is the map of Ceres, just at using the images that Max just showed us to make. And if you still remember what Max showed, there are some little blobs on the surface of Ceres and then rotate across the disk. And if you look at this map, you can actually find all those features here. And as I said for what we did for Vesta, we did the very similar thing for Ceres here. We took out some photomagic effects from the center to limb, and then we unwrap them and we project them on this kind of longitude latitude coordinate, and then put them all together. And what's shown here are actually 3 maps. They are actually they are the maps that you see through different I can say through different color filters, or maybe different color glasses. The first one is green light. So if you put on a green glass and you look at Ceres, that's what map that's the map you see. And then the middle one is purple color. And then the last one, the bottom one, is actually in a UV. So if you put a glass that does not block UV light but block visible light and let UV light go through, that's what you see about Ceres. Of course, we do not see UV light. I want to point out there are 2 things here I want to talk about. One is that you do see a lot of features on it. On the top panel, you can see we actually put in a lot of circles over here. That tells you where these features are, and we also number them in order to just talk about it. But I'm not going to go through all of them. But I just want to point out that these features, some of them are brighter than others. Some of them are darker. And I should say the color are actually not real. These colors, we just use these colors to tell you how bright they are and how dark they are. And there's a color banner at the bottom of this figure. So so one thing is that you can see all these figures, but then when we look at how bright these bright features are compared to dark features, we found that, just like Brittany just said, the change is very, very small. It's very subtle. So if you compare to the moon, the bright highlands, we all know the highlands are brighter than the Mare, and then the highlands are actually almost twice as bright as Mare. And then for Vesta, it's about like the bright area is about maybe 50% brighter than the dark area. But then for Ceres, it's much smaller than that. It's only about like 10%. So if we really use our eyes to look at Ceres, and I would say we probably were not able to tell the difference in brightness of these features. And the reason that you can see those features in the image that Max showed is just because we enhanced it. We enhanced the contrast in order to see those features. But in reality, these features are just so mild. So what are these features? I mean, if you compare the maps at different colors, you can see that they're almost totally different. Some features like number 9 or number 10, I don't know whether you can tell. You can see these numbers. They appear to be darker. Yes, thank you, Nicole. Appear to be dark in the visible, green light. But if you move to the UV light, the bottom one, looks like they're getting brighter. So that's very interesting. We do not know what these features are, what the compositions are yet. That's because we just know too little about what the composition series is, and that's something that we hope Don will help us to resolve. So.
Yeah, that's one of the big enigmas for Ceres, is that it just doesn't seem to behave right in so many ways, right? So it's big and round. It's super flat. The spots don't stay in the same place. I mean, they don't stay there in every wavelength. So you know, it's easy if you think it's you know, if you think you've maybe got a crater, you would normally see it in the topography. You'd see it in surface materials. You'd see an indication of it. It's really hard to get a handle on what's going on at Ceres. So and this is true not just for Ceres, but also for other asteroids like it. So Pallas is a little bit like this, Themis is a little bit like this, Hygeia is a little bit like this. They're these kind of big, dark, relatively flat spectra, relatively nondescript observations that we have so far. So one of the cool things, at least for me, is that we think of Ceres as kind of the maybe the gateway to this other class of objects. It's the first time we'll get up close enough to be able to understand what it is that these data sets that seem to be telling us one thing on one side and one thing on the other side really mean. And then we might be able to actually take that and expand it to other asteroids that are similar, and actually be able to make a comparison set. So that was, you know, that was actually what my thesis was about, was using the same camera, as it turned out, that Jian-Yang that we used for Vesta, we ended up using for Pallas, which is the second largest asteroid. That's kind of it's kind of like half between Vesta and Ceres in a lot of ways, and trying to make that full comparison set of these largest objects. But there are fully 4 or 5 other objects that are very much large, important asteroids in the asteroid belt, for which we don't even have Hubble data yet, really, not any really good stuff. So we keep putting in these proposals and hoping to get some time. So hopefully we'll actually get a data set like that for these other asteroids, especially once we know what we're looking at with Ceres. Be really exciting. So
we have some questions about the smoothness, actually. Tiago Bonito is asking, does it mean it could have a young surface? And Writing with Robots asks if the smoothness hints at a place that is Europa-like or Enceladus-like. Are you willing to speculate on that?
Yeah, so actually what we think, it's unlikely to be Europa or Enceladus-like. So Europa and Enceladus are both objects that have influence of tides all the time, so the tides really help them out. They're also, Enceladus is much less dense, so actually Enceladus is kind of a weird one. So if you move Enceladus to the asteroid belt, it actually turns out to only be about the 4th or 5th largest asteroid. So it's actually less than half the size of Ceres. So, and that's just in extent. So Ceres is massive compared to Enceladus, and not quite as big as Europa. So Europa is about twice or about 3 times as big as Ceres is, and way bigger than Enceladus. But Enceladus has a density of about 1,600 kilograms per meter cubed. Europa has a density of about 3,000 kilograms per meter cubed, and Ceres has about 2,000 kilograms per meter cubed, which is actually really close, a lot closer to Callisto. Because Ceres doesn't have a ton of tidal input, we're not quite sure if there's enough energy to continue to keep the interior warm or to fully differentiate the planet. However, it gets a lot of energy from the sun, so depending on how efficient it is at using some of this energy and how fast it formed, that'll really tell us what the interior is like. So I think the interior on Ceres is less likely to be active than it is, for instance, on Europa. But it has a lot more radiogenic material, for instance, than Enceladus would. So it's maybe a little bit more like that. But if you think about Callisto, which is bigger than Ceres, but it's actually an object that is partially differentiated, and it probably has an ocean layer. But if you think about its surface, it's kind of an older surface. So we're thinking that it may be somewhere between those two. The interesting thing about it is that because Ceres is so much closer to the sun, water ice isn't actually stable on its surface. So the water has to be buried, which means that there's a lot of heating and a lot of dynamics that might happen because of that heat. So it's very possible that it could be a relatively young surface, but it would be a different process than on Europa, where we think it might be coming from the interior, whereas on Ceres it may be working its way from the top down. Certainly originally we think Ceres probably had a big water layer. Whether it's still there or not, unfortunately, we won't be able to know, but we'll have some indications of what might be going on. So it's a real possibility since we don't see any topography. So if you look at the topography of the icy satellites, they're very smooth. They're kind of cue ball-like. And at this resolution, they would look very similar, at least in terms of topography. And that's because ice, when it's relatively warm, relatively, being an interesting word, so even at 150 Kelvin, right, it actually can flow. So that's why glaciers work like that, all of that. So ice flows a lot faster than rock, so it can actually kind of erase some of that signature of topography. So you could have a surface riddled with craters that we can't see because the craters have become really flat. They've relaxed out and they've kind of become flatter. The ice has reprocessed it. If it turns out to be icy, which we think it probably will be. But there's a possibility that it's an old surface that's kind of just rebounded, or there's definitely the possibility that all of that extra energy from the sun and kind of a vigorous early period may combine to make Ceres a younger surface. So it'll be really cool to go and find that out.
Yeah, Sylvan Westby also asks, I know you, Jian-Yang, you said we're not sure of the composition of some of these areas, but do you guys have any guesses about the composition of the surface of Ceres from the data that we have so far and how it might be different from Vesta? Particularly asking about those white spots.
Well, since we do not really know the exact composition of the surface, we do not really know what are those bright spots. Well, I should say that we have a number of explanations for what are they. I mean, for what are on the surface of Ceres from the spectrum. The spectrum of Ceres is kind of flat and kind of featureless, but there are some complex, very complex feature in the 3 micron wavelength band, and that band has been studied for like 20, 30 years, I think. But then people still don't understand what it is. People propose that there are like a number of different possibilities. There's just no conclusion yet. But one interesting thing about all these possibilities is that all these possible minerals require a water-based origin. So that means it's very possible that water could be very close to the surface of Ceres in history. But
that's what I'm pulling for. I'm pulling for those white spots being ice geysers. And in my fantasy scenario, as Dawn goes into orbit, not only does it verify that it's ice, but there's actually like fish flipping around on the surface.
Yeah.
And then you can just clear the space for your Nobel Prize, on your show.
You heard it here first, Hangout viewers.
That's...
Yeah, unfortunately, those bright spots are only slightly brighter than the background. So that makes it hard.
Yeah, that's something to keep in mind.
We have a question from Michael Jobin asking if there, and I know this was something we wanted to touch on as well, is there a moon or satellite hazard for Dawn? And I know that there is some effort going into looking for satellites around these objects. Maybe you guys can touch on that a bit.
Yeah, so with Hubble, we've conducted moon searches for both Vesta and Ceres, several attempts. Obviously, we failed, or that would be like the headline of today's Hangout, right? So I think we were especially disappointed with Vesta because, with that big impact crater, you just think something must have gone into orbit around Vesta, and I really thought we were going to discover a moon of Vesta. And then we also used the Dawn spacecraft itself, of course, as it went into orbit in July of 2011, using the framing camera, and obviously did not discover anything. And so now here comes Ceres, and we've had some telecons lately talking about how to use the Dawn spacecraft, and we will. And there's a nice plan, coming together. But in that telecon, it reminded me that we should really try with Hubble again, because I'm going to screen share just quickly the last moon search attempt. We were forced to use the old wide field planetary camera 2, a camera from 1993. And we obviously have a camera that was installed in 2009, 2 generations better camera. And so here's one of the shots from the moon search back in 2009 using WIFPIC 2. And so it's an intentionally overexposed image of Ceres down there at lower right, looking like a bright star. So Ceres is all washed out, so we could take a deep exposure of the area around it. And you see a lot of cosmic rays and artifacts like diffraction spikes and saturation. And I'm going to click to a cleaner frame so I can clean out the cosmic rays and things like that. And then in the next frame, I kind of flatten the image to suppress the brightness of Ceres itself so we could search. And you see a lot of blips around there, but we know that they're just like residual artifacts from the camera and cosmic rays. Obviously, we didn't discover anything. But we did a fair amount of that, and unfortunately, we didn't find anything. But in our discussions last spring with how to utilize the Dawn spacecraft, we realized we should submit another Hubble proposal to use the newer camera, the Wide Field Camera 3, which is a much better camera, and give us one final chance next spring to try to pull a rabbit out of our hat. And obviously, we'll have another hangout if that happens.
Yes, we'll schedule an emergency hangout. That would be super big news. I would love that. Yeah. Star Trek fans, that the name of that program he's showing is DS9. It is named after the DS9 you're thinking of. Astronomers are nerds, so we'll go with that. So it sounds like you're not worried about it being the moon's being a hazard. It's more of like, ooh, that would be really interesting scientifically.
Well, it's interesting. I mean, in principle. Yeah, I mean, even if there was a moon or two, it's unlikely that the spacecraft would slam right into it. Mm-hmm. But, we've done similar searches for Pluto, and it was considered a possible hazard, not because of the moons themselves, but because of, for very small bodies, they have almost no escape velocity. You stomp, a small micrometeorite impact could send dust into orbit around Ceres, and so it would probably be the dust particles that it might spray into the region around Ceres that would be more of a threat. But obviously in the absence of any moons, there's no possibility of that. So, but certainly it was a concern for the New Horizons spacecraft at Pluto but of course we know of 5 moons of Pluto, and at the moment we know of 0 moons of Ceres. So obviously less of a concern.
You're being very modest. I believe you discovered 2 of those moons. So. Right?
Yeah, that's right. Yeah, I played a similar role for the New Horizons team, and we over the last since 2005 have discovered 4 moons of Pluto. Yeah. With Hubble, and I was hoping to do the same thing for the Dawn mission. We still have one more chance, right, Brittany? Right, John?
Yep, exactly.
So we have a couple of questions about Dawn itself. Tony Darnell is asking, can we talk a little bit about where Dawn is now on its way to Ceres? And also, Hugo's asking, how long does Dawn have, whether Dawn has its thrusters on while it's on its way to Ceres?
Yeah, so, well, Dawn is flying away. We've actually got I don't know, do we still have that up? I think we still have a way to track Dawn online. I was going to see if we could find that.
Oh, yeah, totally.
So there's on the Dawn website, there's actually like a Where is Dawn Now link, so you can actually go on there and find out where it is. And so yeah, we're cruising on our way and looking for our 2015 arrival.
Yeah, 2015, I think we mentioned in earlier Hangouts, the year of the dwarf planet, because we'll have New Horizons showing up at Pluto and Charon, and then and Dawn showing up at Ceres. So that'll be very exciting.
So I have a little question.
Yes.
So in response, it's back a little bit here, but there's a response to talking about how the fact that we actually have a spacecraft that went to Vesta and that could affirm the data that Hubble had developed there. How does that help with the Hubble Space Telescope observations of other asteroids and possibly even other bodies in our solar system and in other solar systems?
Wow, in our solar system and other solar systems. Well, I guess the way that Hubble tells us is that the reality check between Hubble and the Dawn. Just the most important thing is that now we know that what we have done with Hubble images are more likely to be correct. So in the future, we will have more confidence to do a similar thing for other asteroids. That's my understanding. Brittany, you want to say something?
Yeah, so another way is kind of like we just talked about with using the Hubble data to predict what we'll see at Ceres. Because there are these other asteroids out there, we may be able to use those same techniques that Max was mentioning to be able to get a lot out of that data set and have some confidence that we know what we're talking about when we go there. As Max mentioned, a a lot of the really heavy lifting that we've done with Hubble Space Telescope was before we even knew we were going to have dawn, and then and a little bit separate from it. So what's great to do is to be able to know that when we're applying these filters and that we're working with this data set, that we're doing the right thing. If we predicted that there was a big crater on Vesta, and then there wasn't one, we'd have a problem. But instead, we knew that that it existed. We found surface variation. It'd be really cool to have another data set, especially because Ceres is a little bit more difficult to understand. So it really is pushing the limits of what we can do with those kind of pixelated things. So.
And probably the perfect example is we mentioned Pallas earlier, that Brittany studied, for her PhD thesis, and unfortunately the Dawn spacecraft isn't going to get to Pallas, but certainly the truth that we got at Vesta about it, we applied all those same techniques and everything, so it gives us more confidence that what we saw with Hubble for Pallas is valid. It's real features.
So you guys have shared the link showing us where you can see where dawn is right now. I've added the link to the comments on the event page.
I can show you too.
Perfect. Let's do that. Ooh, here we go.
Can you see it? There you go.
There we go.
So this is an image. So if you go on to the Dawn website, you'll actually be able to click on a whole range of different visualization tools. So this is a snapshot, and then this is giving you the distance from Vesta, the distance to Earth, the distance to Ceres. So it's giving you exactly where dawn is and what it's looking at. But if you go onto that website, you can actually look in the direction of Ceres from dawn, look in the direction of the sun. So it gives you a lot of different perspectives for what's been going on.
That image makes them look so close, like they're right next door. Like, why isn't it there yet?
Yep, well, Ceres is running away from us, so we got to catch up.
Okay, and apparently YouTube comments now allow links, so I've added it if you're watching on YouTube in the comments as well, so you can go check that out for yourself. So we're at the top of the hour. I want to ask if there are any last questions from the audience. Any burning questions we can get to. I think there was one I wanted to mention. Oh gosh. Oh, from Diego Benito. Being icy, is it possible that it's a migrant from the outer solar system? Talking about Ceres.
So that's been suggested. It's possible, but it's not required. So that's the big question. We always think, oh, could this have moved in from the outer solar system? And yeah, it probably could have. Its orbit would probably look very different. When you move something that significant a distance, at least a small object, when you scatter it in, the orbits end up looking very strange. That's what centaurs and comets and end up being. That's why they're on those very odd orbits. So Ceres is on a perfectly stable, perfectly circular orbit, right where you'd expect, from this observational Titius-Bode law, right? It's exactly where you'd expect another planet to be. So it's probably no accident that it's there. It probably formed there, and there's a lot of objects in the asteroid belt. If Ceres was the only one that's icy, that would be a really good question to ask, and it's a really good question anyway. But because there are so many other objects that we think now are icy asteroids, big icy bodies that formed in the asteroid belt, it's really changing our picture of how the solar system formed. And so requiring it to come in from somewhere else is not only is it probably not all that feasible, depending on who you ask, but it's just not required. So that's really exciting, actually.
Nedim Selek is asking, when will we see the first pictures of Ceres from dawn?
2015.
2015-ish. We don't have anything more.
Yeah, there's no. One of the things that we're doing is to be really, really careful about our approach. So trying to save as many turns of the spacecraft and as much ion propulsion as we can. Because we had an extended mission at Vesta, we're trying to save as much as we can for Ceres, so that maybe we got the chance to stay on there. So it means that there isn't a releasable plan at this point in time. So 2015, look out for it.
Okay. And we have a couple people, and I'm sure you probably can't quite answer this one, asking, is there an extension beyond Ceres? Is there something for Dawn to do beyond?
Yeah, well, that's the kind of thing that you would propose for once the main mission is over. Probably we're not leaving Ceres. We'll probably go into a parking orbit or something like that. That would be my best guess. We have reaction wheels on the spacecraft, so we're down to using just a smaller set of the reaction wheels than we originally had. So moving on from Ceres probably isn't the best course of action, but as we've seen with Kepler, right? So the new release that Kepler might be usable again in a different mode. So you never know. So it's something we can't predict at this point in time. One of the options is to stay longer at Ceres, go down lower. That's a really good question to ask right now because we know that planetary science is facing a huge, huge disproportionate budget cut. And so that's the kind of thing that, right now NASA's might have to choose between Cassini, which still has a couple of years of existence left, and MSL, which could exist for a long time. We may have to choose between two of our most important, biggest, greatest missions to date because we don't have enough money. So it's the kind of question we just can't ask yet. I wish I could give you an answer. Yes, we're staying at Ceres, we're going low. The orbital mission at Ceres is a lot shorter than it was at Vesta, even in the nominal mission, and a lot shorter, especially considering that we had an extended mission at Vesta. So, man, I would love to stay at Ceres as long as we possibly could. I really hope that things turn around and that we get enough funds to be able to do something like that. That would just be wonderful.
Awesome. I'd like to get a comment from each of the three of you to end the show. What is the thing you're most looking forward to seeing at Ceres, other than fish? Because I think that one would win no matter what. But I want to, first of all, thank everyone for watching this Hangout, for participating, for asking questions, leaving comments. This Hangout will be available recorded for you to see at any time. Please do check out the NASA Dawn site. They've got a lot of great stuff up there, including lesson plans, things you can bring to the classroom, to your students, to your kids, and we're working on one at CosmoQuest as well called Investigate. Yes, that was on purpose. So you can also tie in your asteroid mapper citizen science into
Oh yeah, asteroid mappers.
Yeah, we still have the Vesta images that still need to be looked at. There's so much data.
We really need help with that asteroid mappers data.
So be sure to go to CosmoQuest and choose asteroid mappers to explore the surface of Vesta. You will get slightly addicted, I guarantee you. Personal guarantee, because I have already. So yeah, thanks for watching. If you're looking to our,
or were you gonna go and have them look for their forward-looking moments, or?
Oh yeah, let's. Yeah, I was just gonna say tomorrow. Tomorrow is the weekly Space Hangout with Fraser Kane will be hosting. That's at noon Pacific. We'll be covering probably the last 2 weeks worth of space and astronomy news since we took off for the holiday, and you'll get all your Comet ISON updates from us tomorrow. Virtual Star Party is Sunday evening. It's now at 6 p.m. Pacific, so be sure to tune into that. Look through our astronomers' telescopes all over the world, and without leaving your warm bedroom. It's great, I'm telling you. Then Monday is Astronomy Cast, so be sure to tune in as Fraser Kane and Pamela Gay record a live episode of Astronomy Cast on Google Hangouts and answer your questions as well. So with those out of the way, I'd like to get from each of you your final thoughts on what you'd most like to see when Dawn gets to Ceres.
Well, I'm on record as hoping for fish already, so I guess I'm going to have to stick with that one. But I'll just close by saying that it's been just tremendous fun for me to work with the Dawn team, a really great team of scientists and engineers over these years, and I look forward to more of it. It's been great fun for me, and I think just really satisfying to know that the Hubble Space Telescope has been able to provide all kinds of support and enhance the mission of Dawn. And I certainly expect that collaboration to continue.
Awesome. Jian-Yang?
Yeah, well, similar to Max, I really, really want to see a lot of water on Ceres. We know there might be a lot, but we haven't seen it yet, so that's what I wanted.
And Brittany?
Oh yeah, you guys have heard this a lot from me.
Let's hear it again.
What am I going to pick this time?
Yeah.
I'm looking for things that tell me there's ice underneath there.
Yeah.
So that's what I'll be looking forward for.
Very cool. Me personally, although okay, my camera's freaking out. I will be looking for more questions to include on the Science Olympiad test, since Ceres is the featured object for the Science Olympiad test that I just did an invitational for. So I'll be looking to grill those middle school students on their Ceres knowledge. So yeah, keep it coming. Thank you so much, everyone, and thanks for joining us on this special Google Hangout.